Good evening, ladies and gentlemen. Your host, Golden Zulu. So today we'll look at one subtopic of differentiation, that is marginal functions. So with marginal functions, you will find different terms, but specifically there are terms which they love. So under marginal functions, you will find a term which is referred to as the demand function, where the demand function is always given in terms of P, where it is in this P that some equations they are derived from. So if you were to multiply the demand function, which is P, by Q, you will get what is referred to as the total revenue. So total revenue is given as the product of the demand function together with the quantity. Whereas if you were to differentiate the same total revenue, it will give you what is referred to as the marginal revenue. So marginal revenue in this case is the derivative of total revenue over the derivative of quantity. So with me today, I will work with the consumptions function in how to derive the marginal propensity to consume together with marginal propensity to save from the consumptions equation. Where as well, I will look at how to derive the average revenue together with the marginal revenue, and how to determine the total revenue, and to determine how the total revenue is found when we maximize the marginal revenue. So with me, I have 3 examples to help me deal with what I'm looking at today. So these are the 3 examples that I have. So the 3 examples that I have today, we have the first one, which is given the consumption function is equal to that. Write down the equation for marginal propensity to consume and marginal propensity to save. So this is how we will find the marginal propensity to consume, and we'll derive the marginal propensity to save from the marginal propensity to consume. So this is how we would deal with the work. So for us to get the marginal propensity to consume, we would differentiate this. So the derivative of consumption over the derivative of income, we know to say the derivative of every constant number is 0, where if you were to differentiate 3y to the power 0.4, so 0.4 times 3, that is 1.2, and you subtract minus 1 from the power, and you will get negative 0.6, where we know to say a to the power negative 1 is the same as 1 over a. So this simply implies to say 1.2 is the same as y to the power 0.6. Remember, the derivative of consumption to the derivative of income gives us what is referred to as the marginal propensity to consume. So for you to find what is referred to as the marginal propensity to save, we know to say marginal propensity to consume plus marginal propensity to save is equal to 1, where we know to say the marginal propensity to consume is what we are from finding. So 1.2 over y 0.6 plus marginal propensity to save is equal to 1. Then it is from here that we just group the like terms. So marginal propensity to save is equal to 1 minus 1.2 over y 0.6. So this is the marginal propensity to save function. Then the second question here reads to say, a monopolist is faced with a linear demand function which is given by that, which is P is equal to 50 minus 2Q. We are told to say we should find the average revenue together with the marginal revenue. So what we basically do here is, so for you to find the average revenue, we know to say for us to even get the marginal revenue, remember in our preamble we said the marginal revenue can only be gotten when we multiply the demand function with what? Q. So the total revenue in this case is, so we multiply this times Q, where Q is the quantity. So Q times 50, that is 50Q. This times that one is what? Negative 2Q squared, like that. So from here now, for you to get the marginal revenue, you will find the derivative of total revenue to the derivative of what? Quantity. where you know to say the derivative of 50q is 50 and the derivative of negative 2q squared is negative 4q. So this is the function for marginal revenue. Then for you to get the function for average revenue is equal to total revenue divided by quantity. So total revenue in this case, remember total revenue got above, so 50q minus 2q squared over q. So in this case, we will share the q, or rather you will factorize the q on top. So you can say q 50 minus 2q over q. So q and q are out. 50 minus 2q is the function for the average revenue. But if you were to check nicely, this average revenue is the same as the demands function. So in conclusion, if you don't want to stress your fingers, you can say that the average revenue is always equal to the demand function. Then from here, we have the third question here, which reads to say, the demand function for a good is given by that equation. Write down the expression for total revenue and marginal revenue. The second question here reads to say, calculate the output at which total revenue is a maximum and confirm at this point that total revenue, I think it is supposed to be marginal revenue. Marginal revenue here. Marginal revenue is equal to 0. So what we do here is we just need to find the function for the total revenue, and it is from the total revenue that when you differentiate it, you will get the marginal revenue. So this is our calculation for total revenue and marginal revenue. So we know to say, remember we have P is equal to 50 minus 2q. This equation is the one like on top. So you can just go directly. We know to say total revenue is equal to 50q minus 2q squared, where marginal revenue is the derivative of the total revenues function, where it is 50 minus 4q. So this is the marginal revenues function, and we have answered our first question, which is our A in this case. Then our B question here reads to say, calculate the output at which total revenue is maximum. Remember, we have what is referred to as the maximum and the minimum point in differentiation, where we know to say for you to get either the maximum or the minimum point, you use the first or the second derivative. So what we do in this case, for us to determine at which point is total revenue maximum, you will say total revenue is equal to 50q minus 2q squared. Remember, we want to find where total revenue is maximum, so you differentiate it. So it will give us 50 minus 4q. Remember, we know to say immediately we differentiate it, we will have dtr over dq, where in this case, for you to find the maximum point, you set this equal to what? 0. So in this case, we will say 0 is equal to 50 minus 4q, where we will say 4q is equal to 50. Here we have grouped the like terms. So for you to find the value of q, we will divide both sides by 4, where we know to say 4 into 50 can go there how many times? That is 12.5 times. So calculate the output at which total revenue. So this is the output at which total revenue is maximum. Then they also want you to confirm that at this point, marginal revenue is 0. So you get your marginal revenues function, which you know to say it is 50 minus 4q. So we will have 50 minus 4. Remember, the value of q in this case, it is 12.5. Remember, the reason why we are getting 12.5, the question clearly stated to say confirm at this point, meaning at the point where total revenue was maximum, confirm that the marginal revenue is 0. So from here, you just multiply 4 times 12.5. You will get your answer to be 50 minus 50, which is equal to 0. Hence, confirmed. So we have confirmed to say that at that point, marginal revenue is 0. Thank you, your host, Golden Zulu.